Hello friend, myself Sanjeev Divedi, and on behalf of Vidyalankar Institute of Technology, I welcome you all in this conceptual video session for the subject Advanced Algorithm. In this particular video, we are going to talk about amortized analysis. Now the point is, what is amortized analysis? You must have done analysis of various algorithms and you must have concluded best case, worst case and average case complexity of the algorithm. Now, the point of discussion is for a given input, let's say if I'm executing an algorithm and what happened is, let's say at a particular step or at a particular input, the algorithm performs worst, correct? Or the algorithm is quite expensive in operation. A particular operation is very expensive. Then what we normally conclude is that's the worst case complexity. Correct. Now, even when it comes to bubble sort, we always write that big O of n square, that worst case analysis. Now, see, what happened is in amortized analysis, we do not consider the output or the time consumed by any one such operation. Now, remember, if it is not amortized, what normally we do is we normally express the time complexity in terms of worst case on the basis of output of any single operation, correct? But in amortized analysis, what it says is we will not conclude on basis of one single operation. We will calculate the time required for all n such operation and we will divide it with the value of n. So basically in amortized analysis, the important point is we are interested in finding the average cost over the sequence of operation. Okay, so what it says here, we will not consider one operation but sequence of operation, and the average cost over the sequence is what I'm interested in. So when it comes to probabilistic analysis, what happens is average case running time, average of all possible input for one algorithm, and if using probability, what we get is expected running time. Now, in amortized analysis, we will not involve probability. We are going to find average performance of sequence of operation, even though some operation is expensive. It may happen that some operation is expensive and some operation are very less expensive. Now, but when we will average it out, we can get the average performance of each operation among the sequence, even in the worst case. Now, things may appear quite blur. What I'm talking about average of operation, let me demonstrate you this concept with an example. Now, when it comes to amortized analysis, first we will see what are different methods. We can have aggregate analysis, we can have accounting method, and we can have potential method. Now we will see one example of each. Let's talk about aggregate analysis. Now, in aggregate analysis, what it says is we will identify cost of each of n operation. We will identify cost of n operation and we will divide it by n. So that will give me aggregate, as the name suggests. We will find cost of n operation and we will divide it by n. The result that we get will be my amortized cost. Let me demonstrate you. Now let us see amortized analysis for stack operation. Now it says if I am pushing any element x in a stack, let that time required be big O of n, constant time. Okay. Now if I am popping an element from the stack, or obviously I don't have to specify which element, the element at the top of the stack will be popped. So the time complexity is big O of 1. That's constant time complexity. Now, if I'm performing multi-pop operation, now what do you mean by multi-pop operation? Suppose I say pop 10 element from the stack. Now there is an issue. It may happen that my stack may contain only 8 elements. Only 8 elements, and I have asked it to perform 10 pop operation. We call it as multi-pop operation, back-to-back pop operation. Now in this particular case, even though I have asked it to perform 10 pop operation, it has 8 elements, so 8 elements will be popped. So basically, when it comes to multi-pop operation, how many elements are popped? S is size of the stack and K is number of element I have asked to pop. इन दोनों में जो min होगा वो, जैसे K10 है और स्मॉल एस, नंबर ऑफ एलिमेंट इन द स्टैक 8 है, तो मिन कितना है 8 पॉप होगा। नाउ सपोज अगर मेरे स्टैक में 20 एलिमेंट्स हैं और के 10 है, तो यहां मेरा स्मॉल एस क्या है 20 है, के 10 है, तो इट विल पॉप 10 एलिमेंट। ठीक है, सो पॉप, तो यहां पे देखिए एक छोटा सा व्हाइल लूप होगा जब तक स्टैक एम्प्टी नहीं होगा एंड के ग्रेटर देन 0 है, वी विल परफॉर्म पॉप ऑपरेशन एंड वी विल डिक्रीमेंट इट बाय 1. So here what we see is a push operation take constant time, a pop operation take constant time, and multi-pop operation, sequence of pop operation. ठीक है, we have sequence of pop operation. Now when I say sequence of pop operation, let's say there are n pop operation. ठीक है, if there are n pop in multi-pop, there are n pop operation. Each takes big O of 1. So n pop operation will take big O of n. ठीक है, see the worst case for multi-pop is the sequence big O of n. Why? Every pop will take big O of 1. There are n such pop if the size is n. So there will be n element pop. So what will be the complexity? Big O of n. Now this is one multi-pop. One multi-pop for the stack of size n will cost me big O of n. Now if I am having n such multi-pop operation, if I am having n such multi-pop operation, then my complexity will be big O of n square. Then my complexity will be big O of n square. Now this is what we see. Now we are going to perform amortized analysis on it. Let us see. Now when it says, let's say aggregate analysis. So I'm going to perform aggregate analysis. Let it says sequence of m operation on initially empty stack will cost big O of n. See why? See. Now let us see the things in other dimension. Let us see the things in other dimension. Now we can say even though it is multi-pop, correct? Even though it is multi-pop, but in multi-pop there will be number of pop operation. Okay, and every object can be popped only once. See, each object can be popped only once for each time it is pushed. So ideally we can say the number of pop operation is at most equal to number of push operation, which is n. So number of pop operation will be equal to number of pop operation. So the average cost will be big O of n. Correct? Now big O of n divided by n, because it is aggregate analysis. So what we get is my cost is big O of 1. So when I'm going for aggregate analysis, what I conclude is that there will be, even though there will be n multi-pop, but we can pop only as many element as many we have pushed, which is n. So we can actually push or pop n element only, and each push pop big O of 1. So if there can be n push, n pop, it is still big O of n. Let us divide it by n. So what we get is big O of 1. So what we did is we have averaged out the cost of every push and pop for n number of element, and what we get is big O of 1. So that's one example of aggregate analysis. Now the second method for amortized analysis is accounting method. Let us see. Okay. Now what is accounting method? What accounting method says, you must assign different charge to different operation. Now what do you mean by that, different charge to different operation? Let us say let us take example for stack. Let us say every push operation will charge $1. For example, every pop operation we will charge $1. ठीक है, बट ये क्या, तो what अगर मैं ऐसा कहता हूं तो we have assigned same charge to different operation. ठीक है, push $1, pop $1, but what it says, you must assign different charge to different operation, and the amount of charge is what we call it as amortized cost. Obviously the amortized cost is more or less than actual cost. Now if amortized cost is greater than the actual cost, what we saved is credit. What we have with us balance will be credit, and that credit can be used by later operation in when my amortized cost will be less than actual cost. Now things will be more clear when we see example on it. Okay, let us see this on stack operation accounting method. We will what it says, you will understand things better. Let's say actual cost of every push operation is 1, pop operation is 1, and multi-pop is obviously, if there are s element deleted, then s, or if there are k element pop, deleted means popped, then k. So for multi-pop, it is min of S comma K. But what we will do in accounting method, we will defer the cost. We will change the cost. Now what we will do, we will say let every push operation will be billed $2, for example, 2 unit, or for the matter of fact. And we will not take any charge for pop and multi-pop operation. Now we can do that. Now what we can do is to average out the cost. If I'm supposed to buy two object from you, okay, one object cost is $1, another object cost is $1. Now I can average out the cost by charging $2 for one object and no charge for other. Now how will this make difference? Let us see. Now similar, for example, suppose $1 represents a unit cost. While pushing a plate, let's say in a stack, we are pushing any element. Now $1 is the actual cost. Okay. So, but we are paying what? 2 unit. So whenever I am performing any push operation, we will pay 2 unit to it, or $2 to it. And for pop operation, we will not pay any. We will not pay any. Now, so when it comes to, this is the example cited by Corman, when it comes to mapping it to a stacking of plate in cafeteria, what it says, ki suppose the unit cost is $1. But what happens is when I'm pushing the plate, we will pay $2. So $1 will be used as the actual cost of the push, and $1 will be kept on a plate as a credit. So whenever the plate is popped, that $1 on the plate, we will not ask it from user at that point of time. $1 on the plate can be used to pay the actual cost. Now, so what happens is when I am charging push operation a bit more, there is no need for me to charge for pop or multi-pop. Now, इसका logic ऐसा है, please try to understand. See, for push operation I am charging twice, like $2. But for pop I am not charging any, none. So for multi-pop involves n number of pops, or minimum of S comma K number of pops. So even for the multi-pop I am not charging any, correct? So if I'm trying to average it out, I'm going to perform n push operation, pop operation, and multi-pop operation. Okay. So when it comes to multi-pop, we will say, see, for pop we are not charging anything, so every pop is the charge is 0. For multi-pop, again the charge is 0. So what actually we are charging only for push operation, correct? So if I'm trying to average it out, let's say we will have 2n for n push, and we will divide it okay, we will divide it for n number of operation, okay? So it is 2 means constant time, so we can say big O of 1, because see, try to understand, we are going to perform n push, pop, and multi-pop. So even this n can be represented, 2n can be represented as n. Okay, so it is n by n. So we can represent it as big O of 1, because what it is considering is you're not paying for pops, you're not paying for multi-pop, you're paying double for push. So we are averaging it out. So this type of method is called as accounting method. Again, what we are doing is we are averaging out the cost so that the average cost of each operation is overall low. Now, what is the intention? Be it accounting method or be it aggregate analysis, what it is saying is you try to average out first, find the cost of an operation, divide it by n in aggregate. So what are we doing is we are averaging out cost for n. So suppose if a particular operation is expensive, it is getting divided to n such operations. And even in here we are supposed to perform push and pop and multi-pop. So what are we going to say is to average out the cost, I'm charging double for push and I'm not charging for pop. So these are two methods using which we can perform the amortized analysis. One is aggregate, another is accounting method. For further method we can see the next video. Thank you very much.